Okay, here we go with section 3.6, lines in the coordinate plane. Our objectives: I can graph lines and write their equations in slope-intercept form and point-slope form, and then I can classify lines as parallel, intersecting, or coinciding. So we need to know what point-slope form is and slope-intercept form is. This is all review from algebra, so let's get to it. Here we go with our forms. We need to make sure we know what point-slope form is, what slope-intercept form is. So you've got point-slope form, which is right here, that uses the point x1, y1. And then m is, of course, the slope. So if you look at our example here, our slope is 2, so our slope goes right there. And then our point is 3, 4. And they actually did this wrong on the slide here. This should be y minus y1. And we know the y is the second number. So this should actually be y minus 4 here. It's the opposite of what you see. Since it's y minus y1, it should be minus 4. And the x is the first term, so that should go here. So this should be a 3. So that should actually be y minus 4 is equal to 2 parentheses x minus 3, if we're looking at that correctly, for point slope form. For slope intercept form, this is the one that we use a whole lot in algebra. Y equals mx plus b. We know m is the slope, b is the y-intercept. So you see it in our form here. We've got our slope, we've got our y-intercept. Y-intercept is a positive 6, so we have plus 6. If the y-intercept was a negative 6, it would say 3x minus 6 there. The last couple things there, the equation of a vertical line is x is equal to 5. That is, if we look at a graph, if we want to graph that at 5, if x is equal to 5, that means x is always equal to 5. Y could be anything else, but x is always equal to 5. That's going to be a straight vertical line. Same thing with y here. Y is always going to be 2. No matter what x is, y is 2. That's going to be a straight horizontal line. So you just need to know x equals a number is vertical, y equals a number horizontal. Just a reminder that y-intercept of b is 0, comma b. If they give you the x-intercept, that's the intercept, comma 0. So we can create points out of those x and y-intercepts. That's going to be important moving on. So here we're going to start writing the equations based on some information that they give us. Here they give us a slope is 6 and they give us a point. They want point slope form. Well, they gave us a point, they gave us a slope. We're simply putting it into point slope form. So if we look at this, our point slope form, remember, is y minus y1 is equal to m parentheses x minus x1. So we know our slope is 6, so we can replace the m with 6. The x and the y are going to stay x and y. We just need to fill in the x1 and the y1. Well, it's x minus x1. Our x1, our point here, our x-coordinate is 3. So that would be x minus 3. Now for the y, it's y minus y1. Well, y1 is a negative 4. So we're looking at minus a negative 4. So we might as well just change that to positive 4. So it's y plus 4 is equal to 6 parentheses x minus 3. It's the opposite of what you see. We see a negative 4 here. We need to turn that into a positive 4 in our equation because it's y minus that value. Okay, so the next one, they give us 2 points and they want it in slope-intercept form. Well, anytime they give you 2 points, the first thing you have to do for either slope-intercept form or point-slope is find the slope. We need to know the slope to be able to do that. So the first thing, and you see it here, is they plug it into the slope formula from 3, 5, y2 minus y1 over x2 minus x1. So they do that, we get a slope of 1. Now what we can do is take that slope and one of our points and put it into slope-intercept form. Slope-intercept form, remember, is y equals mx plus b. So we know the slope, we don't know the y-intercept. Well, for right now, we're going to substitute in one of our points in for x and y. That's just a placeholder. We know at the end we're going to have an actual x and y in our equation. But we're going to put that point in as a placeholder right now, along with our slope, to be able to solve for b. So it doesn't matter which point you use, you should get the same thing either way. For this example, they use the negative 1 comma 0. So they plug in the negative 1 for x, the 0 for y. We solve that out. Negative 1 times 1 is a negative 1. We add that over. We're going to end up with a b value of 1. Well, they want this in slope-intercept form. So now we have the y-intercept. We found the slope already. Now we have m and b. That's what we need. Remember, we only put that negative 1 and 0 in there as a placeholder. So we get rid of those now, and we're just going to go to y equals 1x plus 1, because that's mx plus b. They're both 1, and we can simplify it down to y equals x plus 1 on that. So find your slope, take your slope and 1 point, put it into slope-intercept form, solve for b, and then use your slope and your intercept to write y equals mx plus b. Okay, now here they give you 2 points. These are 2 points. This isn't the point 3, negative 5. This is the point 3, 0 and 0, negative 5. Remember our hint from before. The intercepts have a 0 in their ordered pair. So we can take those 2 points and find our slope. Notice that our point, remember, is 3, 0 and then 0, negative 5. Okay? Ignore what I crossed off there. They're mistaken once again on this PowerPoint. But we know better than that. We know it's not the point 3, negative 5. So we use those 2 ordered pairs to find the slope. Once we find the slope, then we can plug what we know into point-slope form. Plug your slope in, and then one of the points, either your x-intercept or your y-intercept. One of them, it does not matter. Here they use the x-intercept. So they plug the 3 in for x and the 0 in for y. And then we just simplify it. We get rid of that minus 0 because we don't need it. There is our equation in point-slope form. Okay, I want you to try it. So try it out, pause it, come on back, see what you have. Alright, so slope is 0 through 4, 6 in slope-intercept form. Well, we can take that and put it into point-slope form because they give us point and a slope. So if they give us point and a slope, put it in point-slope form, substitute in everything that you know. We know the slope is 0, we know the point is 4, 6. Well, that 0 times anything is 0. So that just cancels out the entire right side of our equation there. That whole right side is going to equal 0. We add the 6 over. Our equation is just y is equal to 6. And we know from what we talked about before that y equals a number is a horizontal line. So this would be just a horizontal line, which makes sense because our slope is 0. And slope of 0 is always that horizontal line. Again, I want you to pause it. I want you to try this one. This is something that we talked about already. Find your slope first, then you can put it into point-slope form. Alright, so first thing to do is find our slope. Well, our slope ends up being 0. So if we take that point, or that slope of 0, and we take the slope and plug in one of the points with it, again, that whole right side is going to cancel out. So we're left with y minus 2 is equal to 0. We add that 2 over, and we end up with y is equal to 2. We can either leave it as y minus 2 equals 0, or I would simply say y is equal to 2. That would be a more simplified version for me. Okay, now we got a graph. And I know we've graphed before. Just a reminder, when we graph, if it's in y equals mx plus b, use the y-intercept and then use the slope from there. So our y-intercept here is 1. So you see that point of 1 on the y-intercept, or on the y-axis rather. You see that point of 1 right there. And then our slope is 1 over 2. Slope is rise over run. So that's up 1 over 2. There's our second point. So we can do that and get our line. You always need to start with a point. If it's in y equals mx plus b, your point is your y-intercept. If you're in point slope, then we can simply use the point of point slope. So our point here, if we look, remember it's the opposite of what you see, because this is x minus x1. Well, since there's a plus there, that would have to be x minus a negative 4. So that means our x1, our x value, is a negative 4. Our y value here in y minus y1, our y value is just that 3. So our point that we're going to get out of this is negative 4, 3. And then we've got our slope of negative 2 over 1. So we're going to start with that point, negative 4, 3. Our rise of negative 2 over 1, we go down to over 1 for our rise and our run, and we see the line right there. Y is equal to negative 3. We talked about this. Y equals a number is a horizontal line. So all we have to do is find our y-intercept of negative 3, and it's a horizontal line right through that point. If we had x is equal to a number, it would be a vertical line through that number. Okay, moving on to something maybe a little bit new. If we have 2 linear equations with 2 variables, they represent 2 lines, they can either be parallel, intersecting, or coinciding. And we can figure that out simply by looking at the equation. We don't even have to graph it. A little note here, lines that coincide, that means they are the same line. So they might look different, the equations may be different in different forms, but coinciding lines are the same exact line. If we look at this, when we are trying to figure out whether they are parallel, intersecting, or coinciding, we got to look at the slopes first. If we look at the slopes and the slopes are the same, then they're either parallel or coinciding. But if they're different, we know right away that they are intersecting. So if we have different slopes, we are looking at intersecting lines. Now, we're not saying whether they're perpendicular or what. We're just saying they cross at some point. If the slopes are different, they're going to cross. Now, if the slopes are the same, then we have to look at the y-intercepts. So here we have the same slope, but our intercepts are different. That would be like looking at this, where we have the same slope, but different intercepts. Well, those are parallel lines. And we know from 3.5, parallel lines theorem, that if we have lines with the same slope, they are parallel. So same slope, different intercept, they are parallel. If we have the same slope and then they have the same intercept, the same exact equation, that means they are coinciding. Those are the same exact lines. So they're not just going to come out and give you y equals 2x minus 4 and y equals 2x minus 4 and ask you what they are. They're going to look different. They're going to be in different forms. We're going to have to figure out that they have the same slope and the same intercept to be able to say that they are coinciding. So here we want to determine whether they are parallel, intersecting, or coinciding. Well, here you can tell the slopes right away. They're both in y equals mx plus b. The first one, we've got a slope of 3. Second one, we've got a slope of negative 3. Well, those are different, so these are intersecting lines. The next one, we can't tell right away what the slopes are. We can tell on the first one, right? We know this is y equals mx plus b, so our slope is negative 1/3. But we can't tell over on the second one because we still have that 6 there. We don't have y by itself. So let's get y by itself. Let's divide everything by 6. If we divide everything by 6, we're going to get y is equal to negative 1/3 x plus 2. Well, now our slopes are the same, but our intercepts are different. We've got a plus 5 and a plus 2. Same slope, different intercept, they are parallel. And then our last one here, we can tell the slope of the second equation. The second equation's in point slope form, so our slope is 2. We can't tell anything about the first one. So what we're going to have to do is we're going to have to change at least that first one into y equals mx plus b. They're going to show both of them. Well, here's the first one, y equals 2x plus 8. Now we know we have the same slope. I can't tell if we have the same intercept or not yet. So that means the second one, I'm going to have to solve that second one for y as well. Well, when we solve both of them, we see they both turn out to be the same thing, y equals 2x plus 8. Since they have the same slope, same intercept, they are coinciding. These represent the same exact line. Okay, so here's our check it out example. Solve both for y. You can't tell the slope of either of these, so you have to solve both for y, see if you have the same intercept, the same slope, different slopes, figure out what's going on, see if they're parallel, intersecting, or coinciding. Try it, pause it, come on back. Okay, so if we solve both equations for y, we're going to end up with the same slope, negative 3/5, but we have different intercepts. Same slope, different intercepts, we have parallel lines. All right, here's your quiz. So go ahead, pause it, try it, come on back, see if you got the right thing. All right, so our slope-intercept form is going to end up being y is equal to negative 2x plus 1. And then for the second one, our point slope form, y plus 1 is equal to 2/5 parentheses x minus 5. And there's our graph of our two equations. You should be able to graph based on those equations, or you could graph basically on the information that they give you. Just plot those 2 points for number 1 and connect it, plot the point for number 2 and use the slope, or again, you can use the equation that you came up with. Last couple here, try it, pause it, come on back. Alright, for the first one, we have a slope of negative 1/2, a slope of 2, those are intersecting. More specifically, they're perpendicular, but for our case, we're only asking, are they intersecting? For the second one, we had to solve for y. They end up having the same slope, different intercepts, they are parallel. So that's it for section 3.6. It is review of algebra, but there are some things in there that are a little bit trickier that you have to study, you have to look at. Make sure you go back, you listen to it again, you look at the examples, make sure that you understand all of it. Make sure you know parallel, intersecting, coinciding, all of that. And that's it for section 3.6.